Hi guys, this is the next episode in our today's sessions, and I'm going to introduce Alfonso Sandoval Rosas from Cisco, as he said, and he joined Cisco in 2016, and since I'm passionate about adding value to customers and power coding. Today, Alfonso will show us his presentation and tell us about the network programming, and has engaged in the university and master classes, delivered several coding training at Cisco community, promoting and adopting the DevNet practices and advanced of coding mindset. And of course, you can find him with a GitHub web page. And Alfonso, please welcome you and show us what you do.
Absolutely. Thank you. Thank you for that introduction. And hello, everybody, broadcasting live from Portugal to Lithuania and all around the world. I'm very happy to be here with you, sharing this session about network programmability and beyond. And before I formally begin, let me introduce myself a little bit more. So my name is Alfonso Sandoval, and I'm a software consulting engineer here at the software and automation team in Cisco Systems, Portugal. This is a photo of me that I like to share. It's when I visited the offices in Tokyo, Japan. And you can find me here on my GitHub, my GitLab, which go by the same alias, and also on LinkedIn. If you're interested on following up with the session, I will be more than happy to connect or to have a chat after the session, right? So, before we formally begin, I want to share with you a horror story, which I'm pretty certain that it's going to resonate with all of you here who are data network administrators, data network managers, and people who work on their day-to-day basis with all about networking, which is data centers, security, infrastructure, and so on and so on. This is a personal story of back in the days when the pandemic hit, when COVID-19 totally changed our lives, and everybody was trying to sort out what was going to happen. How could we deliver continuity to our services, to our workplaces in general? And this was a struggle that all our customers had. And back in the days, I was still in Mexico City, and I remember that I was working for one of these big banks. They were our main customer. And if you don't know, the thing about banks is that they need to be able to deliver operation when it comes to trading. So this bank has a lot of teams devoted to trading, right? And if you don't allow traders to do their job even for a couple of hours, their customers, they lose a lot of money, right? Like, this is an operation that needs to keep up despite everything around it, right? So out of the blue, when it became certain that COVID-19 was going to have us locked in our houses, in our places, they reached out to us and they were like, okay, we need to enable all these people, all these traders, to be able to work from home. We need to enable them to work from home in record time because we're losing a lot of money. And so back then I was working with voice and video. So I was in charge of allowing people to use their computers, to use them as if they were phones, right? Like voice over IP phones and video and all this stuff, right? So of course we put a plan together. We're like, okay, we know who are the people that we need to migrate. And bear with me, this was a worldwide thing. Like, all their teams in the Americas, in Asia, in Europe, in the Middle East, in Africa, we needed to migrate them to working from home in no time. So we had the information, we pulled it manually from all our databases, directories, and so on, but it was all spreadsheets, basically. Lots and lots and lots of spreadsheets. We knew the commands. In order to do this network configurations, we had to do some commands. They were easy, they were straightforward, but it was a lot of copying and pasting. So we would have our notepads here and just like copy, paste, opening up a console with this device, via SSH, via Telnet, and copying and pasting, copying and pasting. And of course, you can imagine that in a week worth of work, most of it was troubleshooting, because it was so repetitive, it was so monotonous, and so prone to human errors that we invested more time on troubleshooting, just checking, hey, something's not working, something strange, than actually doing the configurations, right? Than actually pushing those configs into our network. So it was pretty hectic. And all of a sudden, we're like, okay, there must be a better way for doing this. And we found out that our systems, our networking boxes, our switches, our routers, all this and that, they had an API layer. Back in those days, it was very, very primitive. We really didn't have a lot of knowledge about it, but it was there. And a couple of us in the team, we are software engineers by profession, right? Like we studied software engineering, we studied computer science and so on. So we're like, okay, it's time to maybe take off our networking hats for a little bit and put our software engineering hats and analyze the situation from a different perspective. And so we did. We found out that we could pull this information using very basic scripts. Who are these people, these traders, where are they located, what's their phone line, which are their privileges, and we could put all this information, we could condense it into templates, and we could start pushing them automatically, right, using scripts, very basic Python scripts. So that's how we were able to shrink this. We were expecting weeks and weeks of effort. We were able to crush this down into a week and a half. More likely, we were operating this script 24/7, 24/7, and we made it. We saved the day, and it was all due to leaving aside for a little bit this classic approach to networking and really putting our programmer hats on and checking this from this different perspective. And the thing is that we're not alone in this struggle. Nowadays, there's many situations that lead to errors when we're configuring our networks. It's human errors, honest mistakes, of course. Also, it's very difficult to provide monitoring and consistency across a very, very big data network. And it's also very hard to integrate it with our business requirements. And if we put numbers on this, you will see that still today, a big amount of the effort invested on doing network administration is done manually. We're talking about 95% of the changes done on a big network. They're still being done manually. 70% of the things that go wrong are because somebody copied and pasted things in the wrong way. These were human errors. Last but not least, 75% of the operational expenses they are invested in troubleshooting because of all the situations, right? These are consequences of following a decades-old approach when it comes to configuring our networks. And this is more like a cultural shift, right? When it comes to talking about networks, which are the backbone of our IT infrastructure, we tend to think that doing things manually is bulletproof. It's the safest approach to these configurations for a couple of reasons. These are tightly coupled, and networks, they're a different kind of creature. If we compare them against classical applications, I don't know, mobile app, whatever it is, there's many ways for deploying and managing these applications, the software-based products. They can be deployed on a virtual machine. They can be deployed on containers. They can coexist in a local environment, entirely cloud-based, or even a hybrid one. But the networks, they are a different kind of creature. They're getting there, but the evolution is not that fast. Therefore, there's been recently this effort to bring a software-first approach into the realm, into the universe of the data networks. That's why code, as of now, is the new CLI. So we're going to have a look at a series of topics very, very briefly. We'll have a look at different techniques for managing the CLI using code, using some different tooling. We'll see what is model-driven programmability, which is a foundation pillar of today's coding efforts towards data networks. Then we'll have a very quick look to infrastructure as code concept, and DevOps, And finally, if you're interested in following up with this, I'll give you some career tips and tricks, right? So first of all, the CLI. For all of you who do networking on a day-to-day basis, who work with routers, switches, load balancers, servers, and so on, you won't let me lie. It's out of muscular memory that you open up a console, it's SSH, it's Telnet, whatever it is, and you start typing commands. Commands. This is the CLI, right? It's a command line interface. The thing about it is that it was actually designed for humans, right? It was designed for us to clearly understand what are we doing, but to actually type everything that we want, all the configurations, all what we need. We have to type it ourselves. The thing about this is that it actually doesn't map very well when we want to talk through a machine, right? If we want to have, I don't know, a CI/CD pipeline, if we want to have a serverless application, if we want to have some third party who is not a human to talk to our networks, it really doesn't map very well. Because CLI is not an API. It's not an API endpoint, right? It doesn't work that way. So there were some initial efforts, which are still pretty popular today and actually quite useful for some specific use cases, so that we could enable this communication in between an automated third party and our data networks to enable some sort of middleman, right? So that's how this CLI mimicking tools came up to be. These are a series of libraries that we can use in our code so that we can leverage the CLI communication and actually automate some cool stuff, right? If I want to deploy 1,000 configurations on 1,000 networking devices, I can put together a Python script. This Python script will take these configurations, maybe do some templating to change them a little bit, to adjust them to our target devices. And it will be able to convert these configurations into actual CLI commands that I can push little by little into my devices, right? The most popular of this, it's called Paramico. I'm pretty certain that most of you have heard about it. This is like the de facto tool if you're entering into this CLI mimicking world. And it's pretty simple. So what Paramico does is that behind the curtains, it opens up an SSH or Telnet session, and it actually starts spitting the commands one by one to our networking devices. Of course, from the perspective of our network device, it really doesn't make a difference. Our device doesn't know that there's a script talking to it, right? It really doesn't care. For what it's worth, the device thinks that it's a human being there typing all these different commands. But it's in reality this middleman, right? Taking these commands from somewhere else, I don't know, from a Jinja template, something of that sort, parsing them into valid configurations and actually spitting them one by one into our devices, all right? And although this sounds pretty cool, it actually comes with a couple of interesting issues. For example, we cannot really control if our configurations are not valid, right? If I put some configuration, I don't know, like an access control list, right, and it doesn't have all the mandatory parameters, the device will reject it, right? But Paramico may or may know that it's being rejected. It really doesn't care. It's just a middleman, right, in between my script and my devices, my network. And also, it might sound familiar to you that most device vendors, they change their software version, right? And sometimes when that happens, when we go from version A to version B, some commands change. Especially when we talk between architectures, some commands are really likely to change. And what's going to happen is that my configurations are not valid anymore. And I can have this beautiful script, which is helping our company save lots of time and effort. But all of a sudden, we migrated these devices, and this script is worthless because these commands are not valid anymore. And in order to adjust these script to reflect these changes, it will take a lot of time. That's lots of code refactoring. So cases in which this approach is valid, if you're into doing baby steps into network programmability, this might be your jam in order to understand how this works from a programming perspective, and also some very specific corner cases, like some quick fixes, some configurations that I want to have on the go. This is a really nice approach, right? But you may be wondering, if this is not the case, the miraculous Python library, well, what can I use, right? That's where model-driven programmability comes into play. And I love to share this photo. This is a T-shirt from one of my business units at Cisco. I saw it in the desk of one of my colleagues, and I just find it amazing. It's the definition of programmability, which is, as you can read here, capability to accept a new set of instructions to alter behavior, ensure hardware software connects to everything, including the matrix. Pretty important, of course, right? So it was a couple of years ago that the leading companies in the networking universe, they gathered up and they were like, okay, we need to come up with a new standard so that we can enable seamless communication in between our different devices. You know, letting Huawei talk to Cisco, talk to Arista, talk to Palo Alto, and all these different vendors. We need to allow them to seamlessly interact with each other, but also to interact with other third-party tools, right? With my CI/CD pipelines, with any other integration that we may need, so that we can have a seamless closed loop with our business logic, in between our business logic and our network, right? So the solution for this was models. And this is an effort regulated by the IETF, the Internet Engineering Task Force, to standardize and regulate how to describe what my device can do. What does it have inside, and what can it do, right? So that's how we came up with the Yang data models. Yang per se, it's just a modeling language. It is very, very similar to JSON, and it helps us to define, to describe in words, in code, how does my device, how does this router, how does this switch look like in the insides? And we have different types of models, right? We have device data models, which is how does my components look like? I don't know, how does an access control list look like? How does an interface look like? Which are its components, its parameters, and so on. We also have the service data models, which are more for services, right? A BRF, OSPF protocol, EIGRP protocol, and so on and so on. And we have different kinds in terms of who is actually writing these models. We can have industry standards, which are open and they're accessible for all the vendors. Or we can also have vendor-specific models, right? That they will only work for Cisco, for Juniper, for Fortinet, and so on, right? Let me show you how does this look. Let me switch screens here. These models, they are often public, right? Let me bring my cursor here. Great, okay. These models are often public. I have here the public model. It's in a GitHub repo of how to create access control lists for a Cisco iOS XR device. This is Yang code. This is the Yang modeling language. You can see here we have some keywords like modules, prefixes, and it is here where we start describing how does an ACL look like, right? Here we have a prefix list. This prefix list has an access list manager, which has prefixes. And here we have sequences. Here we have accesses, and so on and so on, right? You can see here that this is nothing but a description. I am using the Yang language to model how does an ACL look like inside of a Cisco iOS XR device, right? This is a vendor-specific model. This only works for Cisco iOS XR. However, there are other kinds of models which ideally work for all vendors who adopt them. This is the OpenConfig initiative, and it's a project really worth looking. This is one of these open source projects which has been gaining traction recently. And it's all about industries embracing open source models for their devices. So you see here the equivalent of this. This is an ACL for Cisco iOS XR. It's private, it's vendor-specific, but here we have its equivalent in OpenConfig, right? And you can see that it's a public release in a repo. Anybody can log in and have a look, right? And we have a similar description. Well, here we have some revisions, some identities that are like variations. a couple of things, right? So what is happening now, the trend is that more and more vendors are adopting these open source models, right? Like this open config initiative. And as of now, you can opt for any of this, right? Like inside of the device, you will have definitions in vendor-specific data models, but you will also have open config data models as well. The difference the difference that you will find is that the vendor-specific ones, they may support some device-specific configurations, right? Like there may be some small keys here and there that are specific to Cisco, specific to Fortinet, that you will not find here in the open config equivalent, right? So that's just very important to know. It requires some effort, but well, it's good for you to know that we have both options, okay? And this is gaining more and more traction. So let's go back into our slides. And just for you to have a glimpse of the Yang modeling language in terms of data network modeling, the most atomic, the simplest data type is called a leaf. And the leaf, it has a type, as if it was programming variables, right? It can be a string, it can be an integer, it can be a numeration, whatever it is, but it holds one and one value only of whatever data type we have in there, right? So for example, here we have a host name, it's a string, only one host name, only one string, right? Then we have a leaf list. Leaf list, it's a grouping of different leaves, but they will only have one data type, right? For example, this one, it's a domain search, and it's made up of different leaves. But these leaves, one to many, they can only be strings, right? Then we evolve, a little bit an upper level. We have containers, and containers, it's like this little box. They allow us to group within different kinds of elements, right? I can have leaves, I can have leaf lists, I can have whatever I want, but these are like this logic grouping within. And this comes very handy for creating these logical units, right, that represent things. As you saw, for example, in the access control list data model, we have like the accesses, and this was like a grouping of different things of leaves, leaf lists, and so on, right? You can have one or many different child nodes of different types. And then here we have a list. The lists work a little bit like Python dictionaries, if I may say. It's a sort of key value situation. I need to have a key, and apart from a key, I can have different values within, right? It doesn't have to be a one-on-one. It can be a one-to-many. So for example, this one, my interface, it has a name, but this name must be unique. So that's why the key is the name, right? And apart from that, we can have other elements of different kinds, different data types, and so on and so on. So now we've seen what Yang is and how we're using it to define our data models in our devices. So we have the models, and now it's time for us to learn how to actually use these models to talk to my devices. And that's where these different protocols, these new protocols, come into play. So the first one here is NETCONF. And NETCONF is actually based on SSH. There is an SSH session there in the behind the curtains. But we're actually using RPCs, or remote procedure calls, to talk to our devices. And we have a very specific set of instructions in XML format, so that we can create configurations, we can change configurations, we can delete things, we can get things, and so on, right? It's based on SSH, TLS, and so on. How does this actually work? Well, first of all our devices which are enabled with NETCONF, they have three databases: running, candidate, and startup. Running is the database that has all the configurations that are running now, all the things that are in my control plane, all the things that are right now forwarding data back and forth. These are the configurations in the blue database, the running one. Then we have the candidate. Candidate configurations are the ones that are ineffective right now, but if I can commit them to the running one so that they become effective, so that they come into play. Why do I need this? Well, we use it mostly for dry runs. Like we can have here configurations that may or may not be ready. I'm evaluating which is going to be the impact, but I can have them here ready, right? So just in case. And then finally, we have the green one, which is startup. And these are configurations that will commit into the running database, into the blue one, after my device is rebooted. And I need this, for example, for disaster recovery. Let's say that my data center was shut down for some reason. There was a power loss, whatever it is. And when my devices come back, they come back into power, we can have our startup configurations there so that we can have the minimum requirements for connectivity in between my devices, right? You get my point. So this is how these three databases were cleverly put into play. And this is something exclusive for the NETCONF protocol. So now, there's this dance in between my agent and my networking device when it comes to NETCONF. First of all, if I want to talk NETCONF with my device, I need to create an SSH session. Once it's created, I will send a hello message. That's the name of my message. It's hello. And so that I'm asking my device, hey, can you tell me what can you do? This is very important because my device, inside of it, it has different data models. We saw these two types, the vendor specific and the open config ones. So the device is going to reply to me with this list, with this collection of models, so that I know what can I do with this device. So then I can take any of these models and create the payload that I want to send to my device. It's in between the brackets of an RPC call. And for example, this one that we have on the screen, it has three different sections. First of all, it's my message. It's got a message ID. It's some sort of header. Then we have what I want to do. In this case, in green, it's I want to edit a configuration in the running database. But it could be anything. I want to read a configuration. I want to delete a configuration, whatever it is, right? It's the part in green. And then finally, the payload, right? All this XML, it is actually modeled after the Yang data model that you saw, right? There in the GitHub, it was on this like JSON-ish format, which is Yang. But here I need to put it on XML so that it makes sense. But we have the same parameters, the same data types, everything is here. If I don't know my Yang data model, I don't know how to speak NETCONF with my device. It's as simple as that. And then once we're ready, we send this RPC, and then the device will give us an RPC reply. And once we're done, we send a close session request. It replies with an OK, and we're good to go, right? So this one is SSH based. However, what if I told you that on a pretty similar fashion, we can also talk with our devices via REST, right? You remember REST? I'm pretty certain that everybody here knows their REST verbs. What is a get? What is a post? What is the put patch? If I ask you what does 404 mean, everybody will tell me will give me the right answer. If I ask you what's a 201, a 204, we know REST. We love REST, right? Our REST API endpoints, that's the best thing to have. And what if I told you that we can actually map this into our network devices? This is a pretty recent trend, and it comes really, really handy because for us as software engineers, it allows us to talk to our network devices in the same way that we talk with, I don't know, the Spotify API or any Google API, right? It's the exact same experience. This protocol is called RESTConf. It is also based on HTTPS, and it works in a similar fashion. We have these URLs. We use the same verbs, get, post, put, patch, delete. And the only difference is that this URL, it actually targets a device, and the payload must be in either XML or JSON. And which payload do I send? Well, this payload is actually modeled after, yet again, my Yang data models, the ones that you saw on Git, right? So that's why it's super important to be aware of these data models. Otherwise, I don't have any payload to send. And here, I just want to show you very briefly, you have this URL. It's as simple as that to communicate with my devices via RESTConf, as if it was yet any other given API. Easy peasy, right? Now, I want to share with you very briefly this concept of infrastructure as code. I talked about this in more detail in my other session today earlier, but the thing about infrastructure as code is basically embracing this brand new mindset in which we don't talk about our configurations as just command line arguments that we need to copy and paste. Under this state of mind, we are considering our infrastructure as living code. This is code that we can write, that we can do versioning on using a VCS, any Git provided, and that we can actually manipulate at will based on what we need in this moment, and which, of course, we can integrate with CI/CD pipelines and so on. So this code, it actually describes the intended state of my network. These configurations here on this YAML file, on this JSON file, this is what I want to accomplish, what I want to have right here, right now in my network, right? There's different tooling for this that seamlessly integrates into my CI/CD pipelines. And using the protocols that we talked about before, using NETCONF, RESTCONF, these data models, and so on, we're able to create this closed loop in between my business requirements, the desired state of my network, and the actual state of my network. That's something that we can do putting all these tools all together. And now, just for there's this other flavor about DevOps that I talked about briefly in my other presentation. DevOps can seamlessly come into play when we talk about networking. If we embrace this state of mind of infrastructure as code, we can start treating our networks as code, certainly, and we can integrate all this tooling into DevOps. So DevOps, when it is applied into the networking universe, it converts into NetDevOps, which is this different flavor, a little bit more spicy than normal DevOps, right? And the benefits are pretty seamless. There's early detection of defects. It's easier to integrate smaller changes. The risk of introducing errors due to manual intervention, they're greatly reduced. And we assure that there's more quality when we deploy new configurations in our network, and we can do it on a faster pace, faster pace, with more reliability and overall more quality, right? And these are like sort of the mantras, like the foundation pillars of NetDevOps, which is, as I mentioned before, it's DevOps practices in the networking universe. We should push small but frequent changes, frequent changes in our network devices. Our tooling should be able to roll back by itself, right? Like there shouldn't be any manual intervention. Whenever we know that these configurations are going to be faulty or that they come with some dirt, our tooling should be able to roll back immediately and let us know about this. And well, last but not least, but the most important part, we mitigate disruption risks by human intervention or bad code, right? It's when all this comes into play under a holistic view, having this infrastructure as code, DevOps, NetDevOps, everything combined into a closed loop, right? And here I would just like to wrap up with some tips and tricks for all of you who are interested into following up with these topics. Maybe some network engineers here who are interested in bringing all this good news into their day-to-day practice, or software engineers who are interested in the network programmability or the infrastructure universes, which are really, really interesting. My suggestions would be to reinforce all the software engineering topics, right? So that we can make sure that we're always delivering high quality software. It's some sort of a taboo among network engineers. Like, I'm a networking engineer, I'm not a software engineer. I'm just going to do scripts and I'm just going to deliver them. If they work, it's good, despite not being maintainable and whatnot. Well, this is something that we need to fight against. Everybody can write high quality software. Everybody can follow software quality standards, design patterns, and so on. This is something that we all can do and we all should be doing right now. And on the other hand, you cannot really automate something that you don't understand fully, right? So network engineering part is also very important to have at least the bare minimum concepts of routing and switching, CLI management, and also some expertise on other technologies like data center, enterprise, core, wireless, whatever it is. It really, really comes handy, right? We will always have here our network engineering gurus, but it just feels good to understand what you're automating, right? If you're automating cloud, if you're automating networking, it's good to know how this is done manually so you can really understand the impact of your automation efforts on it, right? And last but not least, just keeping updated. The infrastructure world, it's evolving so fast. And being able to understand and to talk your way through different deployment patterns, different architectures, containers, Kubernetes, etc., cloud providers, cloud infrastructure, hybrid infrastructure, and so on, that's something that will come really, really handy. Okay, so this is everything that I have prepared for this session. Now I would like to hear from you. The microphone is all yours. If you have any questions that you may have, I will be more than happy to answer them. So let me stop sharing my screen.
You ask a question and we'll see how many people understand what you mean. but that was quite nice with the young, right? But if somebody create this code, create those configuration, is any chance to check if everything goes well or will be okay? Because on the last of slides, you show that the software development, unit testing are necessary, right? But how we can improve the testing before the deployment? Is it yeah, you understand me?
Absolutely. There is a different there's a series of techniques for this. In the networking world, testing in the networking world is not as straightforward as in other industries. For instance, on the mobile app development or any given web app, whatever it is, when we create a staging environment, it's pretty straightforward what I need. I need a target OS version, whatever it is, Linux, Fedora, CentOS, whatnot, right? Or in mobile phones, I need a specific Android version, an iOS version, right? And I can put all of this, all my libraries, my Python, my Java, the specific versions, I can put all of this combined on the staging environment and test my new code and run some unit tests, right? Whatever tool you like the most, a robot, PyTest, unit testing, whatever it is. The networking world is slightly different. The networking world, it's not an app. It's not a container. It's not something that I can just spin up and test with. There are different platforms which allows us to create virtual networks. We can simulate the existence of a data network as simple or as complex as we need. We can simulate different routers connected all together, having this network. And the intention here is to have a digital twin of this part of the production network where I am going to deploy my code as similar as possible, right? It rarely is 100% alike, but as similar as possible. And these environments, I can create them and destroy them at will. I can even make them part of my CI/CD. I can even have them versioned as code. And as part of my testing plan, I spin it up, I deploy it, then I bring these code changes, and I can use all these other techniques. Unit testing, PyTest, robot framework, there's ways to do this, right? So that's where this fine line in between networking development and software development becomes really blurry. At some point, they both blend gracefully, so to say.
Yeah, but I'm curious why you're trying to create the young language. Is I made, of course, the name of the languages. Because you said there is first was an iOS and XR. Then that were the problems with some deployments or some quick fix of configuration. That's the really way, or that's the really way that you are trying to to fix the network engineers' problems?
So when it comes to the data models, so you asked about, because we have first the one that I showed, the IOSXR for access control lists, and then I showed this other one, which was OpenConfig, right?
Yes, that's right.
If this is an effort for standardizing everything and making these models open source, 100% open source. This is an open initiative. This is part of one of the Linux Foundation projects that is ongoing. And all those different vendors, they are collaborating together so that we can accomplish this. At the end of the day, the only purpose is that we have an open source repository that allows us to talk with the different device vendors seamlessly, right? So that with the same code, I can talk with the Huawei, with a Fortinet, with a Juniper, with a Cisco, right? That's intention. We're not there yet, but I think that we will be there anytime soon.
It seems to be like a new service in the cloud. And for the future right now. Okay, but it is really nice, really cool that they summarized the configuration, mostly in language for configuration. It is quite nice and easy technique. Okay, there is I think no question about but you can all the guys chat with Alfonso wherever they want, right? Over the LinkedIn, GitHub, Twitter, if you have a Twitter or X now platform, and it is not necessary to ask him here if you don't want. But please, you made to drop the question. But 3, 2, 1, it's no questions. All right, then thank you, Alfonso, and really appreciate to meet you here. And quite nice presentation, and your vision are really nice.
Thank you.
And thank you very much, and welcome you for the next episode this fall. Bye and see ya later.
See you.
Ciao.